Hi, good morning. Welcome back.
I'm in.
How you doing? You doing good? Don't choke now. Don't die. Don't die. You're not allowed. So, what are we doing today?
Rectangle, yeah.
Yeah, rectangles. What's the objective?
I would throw an given, I don't know.
Quadrilateral.
Rectangle.
Rectangle.
Properties, shape, scope, and distance.
Formulas. Do you have glasses, baby?
Evidence.
They're broken. Okay. So, we'll help figure out a way to get you not broken glasses so that you can see better. All right. Let's get into our notes for today. It will be rainbow color throw up all over my notes as per usual. So if you have colored pens or highlighters and you like to color with me, please bust those out now so that you can follow along with the rainbow. A rectangle is a quadrilateral. 4 sides, but it has 4 right angles and all the same properties and things that a parallelogram has. So everything that we've already studied before totally works for rectangles. So we're going to jot those down again. Opposite sides are congruent. Opposite angles are congruent. Opposite sides are parallel. Consecutive angles are supplementary. And the diagonals bisect each other. I see a few people with the textbook on page 423 reading out of the book and filling out from there. Kudos to you. Good job. In addition to these 5 items that are taken from parallelograms, the rectangle also has all 4 right angles. So all 4 angles are right angles, and the diagonals are congruent to each other. Extra lines, because reasons. Okay? Let's use these properties of our rectangles in order to solve some algebra problems. Here we go, getting ready to set those up for you. All right, we've got a quadrilateral, this one right here, ABCD, and we're told is a rectangle, which means all of the stuff from above totally applies to this thing. We're told that BE, here is BE, that it is 6y plus 2, and CE, here's CE right here, that is 4y plus 6. Find the value of y. This is a rectangle. In rectangles, diagonals are congruent, which means they have the same measure. And because it's a parallelogram, they bisect each other, which means this piece is congruent to this piece, and this piece is congruent to this piece, but they're all congruent to each other because the diagonals are all the same length. Which means I can write my equation this way. That diagonal piece equals that diagonal piece. Okay, I'm going to bust through the algebra pretty quick. You guys are feeling more comfortable as I do that. So I'm going to go ahead and continue that. Please make sure that you are following along with the algebra and you have an idea of what I'm doing. And if you're not sure, you let me know. We're okay?
Yes.
Good. All right, let's do the next one. The next one says BC is 24, AD is 5y plus 1. All right, here is BC, 24. Here is AD, 5y minus 1. And I need to find y. But this is a rectangle. And a rectangle is a parallelogram. And in parallelograms, opposite sides are congruent, which means this side has the same measure as this side, and so my equation can be written this way. and I'm going to solve that equation for y. Again, I'm going to fly through the algebra and label my steps. Please let me know which step you might be confused with. We all right with this?
Yes, ma'am.
Good. You guys are really great at this. Next up, we're told the measure of angle AED. Okay, I'm going to start at A, go toward E, turn around toward D. So that's talking about this angle right in here. That is 12x. Then it says the measure of angle BEC. That's this angle right in here. And they're telling me that that angle is 10x plus 20. Find the measure of angle AED. My properties for rectangles don't tell me anything about the angles in the middle of the rectangle. It only tells me about the angles in the corners. But, do these angles look familiar? What kind of angles are these? They're vertical angles. And vertical angles are always congruent, which means I can write up my equation as this measurement equals this measurement. So that's what you're going to see me do. Once again, I'm going to fly through that algebra. Please make sure that you know what I did at each step. And if you need me to explain, let me know. Am I done?
No,
Why not?
because you have to find the measure of the angle.
Nicely done. I still haven't found the measure of the angle, so I'm not done. The measure of angle AED was given to me as 12 times x. Now that I have a value for x, I can substitute. And the measure of angle AED is? And now I'm done. When you're done copying this one down, you feel comfortable with it? Join me on the back side of the page. There's another example at the top of this page. Do you want me to go through it, or are you feeling comfortable with this? Okay. Okay. In order to prove that the thing we're looking at is a rectangle, you've got to show a couple things. Please remember that the diagonals of a rectangle are congruent. This means that if you're staring at a parallelogram and you know that its diagonals are congruent, you can say that the parallelogram that you're looking at is a rectangle. But you have to have a parallelogram first. That's going to become important in about 2 minutes. In the coordinate plane, fancy word for graph paper, you can use the distance formula or the slope formula and the properties of diagonals, that they're congruent, that they bisect each other, in order to show that the figure is a rectangle. And that's what we're going to be spending our time on the rest of the class period. Notice that it tells me quadrilateral, which means I don't know if this thing's a parallelogram. So in order to show that this is a rectangle, I first have to show it's a parallelogram, and then I can show it's a rectangle. Ugh. It would have been easier if we had just had a parallelogram, right? Yeah. All right. We're going to determine whether this is a rectangle, and we're going to use the slope formula first. Who remembers what the formula for slope is?
Over x2 minus x1.
Gorgeous. Y2 minus y1 divided by x2 minus x1. Ladies, can I have you put the phone up for now, please? Thank you so much. Thank you. Appreciate it. In order to show that this is a rectangle, you have to have two things. First, we need to show that the opposite sides are parallel, because that gives us the parallelogram. And then we got to show that the consecutive sides are perpendicular, because that gives us the 90-degree angle to say that this thing is in fact a rectangle. Okay? So we're going to use slope formula. We're going to do slope formula on all of these different lines and then figure out which ones are opposite, which ones are consecutive, and then from there be able to make our decision. Okay? So I'm going to go ahead and color code these guys so that it's easy for me to see which ones are opposite. You guys go ahead and start on the slope and I'll catch up with you, and when I'm all done, we will reconvene and decide, is this thing a parallelogram? Is this thing a rectangle or not? Is it, can you see what I'm doing? Is it big enough? Or do I need to zoom in? I need to zoom in for a few? Okay. You're going to lose some of the coordinates. Is that okay?
Yes.
Okay. Is that all right? Is that better?
Yeah.
Okay, good. Thank you. Bless you. Oh. Sorry. I made a mistake and I caught it.
No.
At least I recognized my mistake this time. Oops. Messed up again. I'm having trouble, guys. I keep messing up.
Miss, what is that supposed to be? Is it -3 equals 3? Or,
Here?
No. No. Wait, messed up.
Yeah, -3, -3 minus 3. Sorry. Thank you.
Oh.
This is a lot of pressure.
After you do that,
I am all sorts of distracted right now, apparently.
Okay, no, what's the other one?
Which one?
The orange one.
1 plus 2.
What? No, the one next to it.
This?
Yeah.
It's a mess up.
Oh, I don't make that?
Yeah, this is the, that's the bad one.
See? Oh, okay.
I'm sorry. Okay. Now, we need to show first that opposite sides are parallel. So I'm going to zoom out a little bit so we can see my color coding. My color coding, the opposite sides are the green and the orange and the blue and the red. So green and orange, do they have the same slope? Yes, which means that AB, line segment AB, is parallel to line segment CD. Now looking at the other pair of opposite sides, the blue and the red, are they parallel? Yes. So then AD is parallel to line segment BC, and I can use that to say that quadrilateral ABCD is a parallelogram. But now I need to show that it's a rectangle. To show that it's a rectangle, I need the consecutive sides to be perpendicular, which means I need negative reciprocal slopes. Slopes have to have a different sign. Are they? One positive, one negative?
Yes.
Yes. And then if I look at them as fractions, are they flipped?
Yes.
Yes. These are negative reciprocals, and AB is perpendicular to line segment AD. Is that true of CD and BC?
Yes.
Yes. And so line segment CD is perpendicular to line segment BC. And so it is also a rectangle. Feeling okay with this one? Good. Now we're going to use the distance formula. In case you forgot, here's the distance formula. I'm going to try not to let myself get distracted. I'll hold my tongue right so I write it all properly. There we go. There's your distance formula. Now, we were told this thing's a quadrilateral. So we have to show it's a parallelogram first. To show it's a parallelogram, we need those opposite sides congruent. That means the distances for BC and AD need to be equal, and the distances AB and CD need to be equal. But in addition to all of that, in order for this to be a rectangle, you also have to show that the diagonals have the same distance measurement. Okay? So you're going to be running distance formula 6 times. You've got your workspace here. I'm going to leave it zoomed out just a little bit so that you can see what I'm writing and all of the coordinates. I will meet you back here in a few minutes after we calculate all 6 of the distances. Please don't wait for me to write them down. You chug through them. Remember, no decimals. Get yourself used to writing with the radical with the square root. And I will see you back here to compare our numbers in a few months. Okay, I'm at the halfway point. Now, hopefully at this point, this distance formula, yes, hopefully at this point, the distance formula isn't feeling, what was I writing? Okay, isn't feeling like really terrible, but instead is just feeling like, oh my God, there's so much to keep track of and so much to write, and I'm getting really bored of writing it. Because if you're at that point, that means that it's really easy for you, and you're doing really well. And of course that you're brilliant. But we already all knew that. Okay, I'm on my last one. That was a lot of work. Okay, let's confirm that it's a parallelogram. For it to be a parallelogram, we need the opposite sides congruent. That is, the green and the orange sides need to have the same distance values. Do they?
Yes.
Yes. That means that that pair of sides are congruent. We need the other pair of opposite sides congruent, the blue side and the red side. Do they have the same distance value?
Yes.
Yes, these are also congruent. The diagonals now need to be congruent to show this thing's a rectangle. Are the diagonals congruent? Yes, therefore, quadrilateral ABCD is a rectangle. That was a lot of work, you guys. I hope that it felt like it was just a lot of tedious, like, writing numbers, and it wasn't really tricky. Is that what you guys are at? Yeah, pretty much? Good, good, good. That means that this is, you've got this, you've got this, you've got this, you've got this. All right, let's turn the page. There's 4 examples, but I don't want to walk through the 4 examples because you guys are already feeling really comfortable with how to use the distance and the slope formula. So what I want to do on these examples is write out for you the steps to follow. So that way when you're doing your homework or you're doing the extra examples, you have this very formula. I'm just going to follow these steps like a recipe. Okay? And you don't have to think too hard. All right? All right. Let's look at the distance formula. If we've got a quadrilateral and we're being asked to determine if it's a rectangle, these are the steps that you want to follow. The first step is going to be draw the figure. Okay? And I'm actually going to draw the figure for you so that way I can color the opposite sides so that way it's easier for you to match up physically with your eyes. Okay? So just going to give it a real quick sketch here. Not going to be anything too fancy. Nothing too fancy. Gonna throw the lines on there real quick. I didn't even make them touch. This is like the worst parallelogram quadrilateral thing in history. But there you go. Okay. So the first step you want to take is show it's a parallelogram. You're going to do that by showing that the opposite sides are congruent. That is, you're going to show that BC has the same distance as AD and AB has the same distance as CD. That gives you parallelogram. Once you have parallelogram, your next step is to show it's a rectangle. And to show that it's a rectangle, you need to show that the diagonals are congruent. That is that line and that line. So you need to show that those have the same distance measurements. And once you've done all that, you can say it's a rectangle. If at any point along this path you get a not equals, it is not a parallelogram or a rectangle, wherever you end up to find it. Okay? Make sense?
Yeah.
Yeah? All right, let's give you the same recipe to follow for the slope, so that way you have it, and then we'll release you to start working, okay? We've got plenty of time. We're sitting at 11:15. Bell rings at 36. So it means we're sitting on about 20 minutes right now, which is a good place to be. Okay. Hi, guys. Give me like 5 more minutes, okay? All right. So you can get your recipe down, so you can do your homework. Okay. Draw the figure. Just like the other one, I'm going to draw my figure. I'm guessing that's where I could put that. I'm hoping it's right. So gonna just, again, give it a really quick plot here. 1, 2, 3, 4, 2, 4, 5, and 3, 2. This does not look like a rectangle.
No.
You know, it doesn't, but I still have to go through the motions. We're using slope formula this time. So please note that this is using slope formula. The other one was using distance formula. In slope formula, you want to show it's a parallelogram. And you're going to do that by showing that both pairs of opposite sides are parallel. That is same slope. Okay? So again, I'm going to color code these here for you so that it's easy for you to see which ones we're referencing. You want the opposite ones to be parallel. And AB parallel to CD. Once you have those parallel, you want to show that consecutive sides are perpendicular. Okay. Now you've got your choice. You can do BC is perpendicular to AB, or you could do AB perpendicular to AD, or any of the corners, basically. And here's the great thing. On our example, we did 2 corners. You really only need 1. If you've shown this is a parallelogram, you only need to show 1 corner is perpendicular, and you're done. All right? We feeling okay on this one?
Yes.
All right, that's all I had for you guys today. Thank you very much.
Actually,